So one thing we see from these results is in the first 2 years, really no response to the lime application. And that's to be expected because it takes time for the lime to adequately react with that acidity to neutralize it so that you get the agronomic effect. But in the 3rd year, we see some increase in corn yield, and then in the 4th year, a nice increase in the soybean yield. We also see throughout that our most consistent and good increases are in soybean. Now with soybean, we say that you don't want the pH to drop below 5.8. If you're continuous corn, you can let it drop to below that, 5.4, maybe in 5.3 without having a significant yield loss. But with soybean, we have to keep it higher. And these results show this. With the corn, it's been rather erratic, the responses, including in 2009, for some reason, the mean yield was low with lime applied. The lines represent cost and income. So the red line is the cost of that lime application. Back in 1995, when they applied it, they estimated $22 a ton for the purchase, to transport the application. Here you probably have to transport it more farther if you're using it. I don't know where you would get it from, but there they were quite close, so their transportation costs were relatively less. And of course, now the price is higher. It's $22, or a total of $44 per acre is what they invested for their 2 tons of application. There were some interest costs until those costs were finally paid off, and then a flat line at about $50 per acre. The blue line represents the gross returns to that lime application. So we see it's like up to $450 per acre. And this is calculated with using $4 for corn and $8 per bushel for soybean. If we use current prices, this would be considerably less or more. The black line represents the net. And so we see the net was below 0 until the 4th harvest. It took 4 harvests before you finally got the lime application paid for. So we're talking about longer term investments. Last fall we went in and took soil samples for the supermedium step to compare with and without lime. And the Malic 3 phosphorus, which is very similar to the Brave 1 phosphorus, was 25 parts per million available with lime applied, but only 12 parts per million where no lime was applied. This effect was much greater than I was expecting. I was expecting that the lime application would help on availability, but not to this extent. The pH where lime was applied 17 years ago, so 16 years before we sampled, was 6. Where no lime was applied, it had dropped to 5.4. And the zinc availability was also somewhat improved with lime application.
Okay, Charlie just talked about the low end of the pH line, the acid soils, and fixing them. I'm going to move over to the higher end of the pH spectrum, talking about chlorosis, sometimes called flat valley yellows, iron chlorosis. Generally found in areas where pH is 7.5 or greater, but it's not really caused by the high pH. It's a little bit more complicated than that. How many of you have some land that has some of that on it? You do. So you've had to deal with this. Probably this isn't new to you then in terms of what you're doing. Variety selection is tremendously important. University hasn't been doing a lot of evaluation. I think in the mid-'80s we had a program trying to evaluate seed, but now we rely on the seed companies to tell you what to plant. Plant density has been shown to help alleviate the system. It seems like there's a dose dilution. If you plant a lot of seeds, you do a little better. I was reading an article this week that suggested from Minnesota that they plant some oats with their soybeans on these areas, let them come up, dilute the chlorotic effect, and then the oats get killed when they spray Roundup. I don't know how well that would work here. I don't know if anyone's actually tried it down here. But it's the same effect of trying to dilute the problem. If you really have this severity, probably the iron chelate is the way to go. You put that in the seed furrow. The recommendation is between 2 and 4 pounds. pounds. I'll show you some research where it looks like from the work that Richard Ferguson did, the 4 pounds may be a little bit high, so you'd want to be careful about overdoing it. Foliar fertilization has the benefit of you can spray when you see there's a problem, but if it's very severe, it's hard to get enough iron into the plant once you start showing these symptoms.
It's true in some parts of the country, nitrogen-free plant application or starter N is recommended. Primarily in the north, like North Dakota, the Red River Valley of Minnesota, they have a recommendation of 50 pounds nitrogen applied pre-plant. Coming farther south in Brookings, South Dakota, they found a 6% average yield increase by applying 15 pounds of nitrogen 2 inches to the side of, injected 2 inches to the side of the road. For the high plains, like Ogallala and farther west, we recommend nitrogen application in small amounts of starter or pre-plant nitrogen. But for most of the Corn Belt, there is lack of demonstrated evidence that we get a response to nitrogen, starter nitrogen by soybeans. We do have that concern though here in Nebraska about heavy residue situations where we have irrigated no-till land and buildup of corn residue, especially with 2 years of corn in a row, but even with corn soybean. Is it likely that in some years when the spring, the soils are slow to warm up, maybe wet, that we might get a response to nitrogen often enough to justify a routine starter N application.
Okay, I'm going to show you 2 graphs that were put together almost 30 years ago, well, actually more than 30 years ago, on soybean nitrogen utilization. Now we've had changes in crops and varieties and genetics, but probably this is fairly still valid. And what we want to look at here is how and when the soybean plant takes up nitrogen or gets nitrogen into the leaves. Part of the time it takes nitrogen up from the soil, and part of the time it fixes nitrogen. That's what a legume does, right, is fix nitrogen. So Charlie has set up some situations out here, and he's reviewed the literature on putting N on in the starter, putting foliar on. Question is, what does the basic physiology say about that? This graph, this line here is soil nitrate getting into the plant. And this curve here is the N that's fixed. Now, if you can read this from out there, this says June, this says R1. R1 is flowering. When's flowering? It's not anywhere near planting, right? So if you have a situation where there's not a lot of soil N, you're not going to start getting nitrogen uptake, utilization of the N from the soybean nodules until here, and it gets more as you go on. You're going to get it from the soil. So if you don't have any soil N early, the plant is going to be a little bit deficient. The other point I want to make with this slide, and these 2 aren't in your booklet, so you'll just have to memorize them here by staring at them for a while. But this triangle you see is very low down here. This is the amount of N fixed. These triangles represent a mixture of soil and 200 kilograms per hectare. That's about 190 pounds of N per acre. You put N in there, and you inhibit this part of the curve. So you've probably heard that before. You put N out, and you don't get this. So if there's still N around at this part of the season, this number is going to go down. And these 2 just show that if you don't have that in there, you're going to get more fixation. We put on either 27 pounds per acre or 54 pounds per acre N, or 54 pounds N plus 4.5 pounds of sulfur at the beginning pod fill. What stage is that? R3. Good. Got it. So we put it on there. The research shows that we should be putting it on there because that's when the corn may need a little bit of a bump. And this line here is the fixed amount of N compared to the total uptake. Just so you can see in the beginning, this is days after planting. It's another way of putting the 2 together from the previous slide. So there's not a lot up here. But of interest to you is that at best, there's a 2.5 bushel increase.
All right, let's switch gears a little bit. High-yielding soybeans, they're all the talk right now. Who here has heard of Kip Culler's, what he's done in Missouri? So how many of you would like to see yields like he's been seeing? Let's see your hands. See it, probably every hand come up. Earlier this spring, several people got together and kind of a think tank to decide what kind of practices can we do here in Nebraska, that some of what Kip has been doing, what can we take from what he's been doing that might work here in Nebraska to help maximize our yield potential. Well, we came up with 5 different treatments. The first is adding 5 pounds nitrogen in seed furrow. We heard a little bit about that previously to help give those plants a quick boost out of the ground, get them, once they come up, get them running. The second, a foliar NPK plus micronutrient package at R3. Again, at critical stage where you've got a full pod, it's starting to fill those seeds. We want to see those pods full of seeds. We don't want them aborting seeds, so we want to give that plant what it needs to maximize that yield. BioForge seed treatment, it's a 203 NPK, has a lot of antioxidant properties, a lot of stress-reducing properties. So if you go into a period of stress, the plant will recover faster once you start coming out of that stress. We'll talk about some ways that we've stressed our beans in this trial. Optimize seed treatment. Probably heard a little bit about it before. Again, it's an inoculant and kind of a plant growth promoter to help get those roots established quickly. You have a good root system, you're able to pull those nutrients into the plant so it can have those higher yields, so it can pull those nutrients. And then we stressed our beans this year. We want to promote branching in the beans. So with more branches on a bean pod, on a bean plant, there's a potential for more pods, there's a potential for more seeds and increased yields. So we came out here with, it says a lawnmower, we took like a weed whacker with a modified blade on it and cut the top part of the beans off, that tip growing point. This was done at V2. In alternate that we've done to that Cobra, the chemical is lactofen, 12.5 ounce labeled rate. We're spraying that in one of these plots to see if that will help. That will kill that top portion of the plant to promote branching. A lot of what Kip does is to spray lactofen to promote branching and control white mold. That's a supplemental label that lactofen has. So with these five treatments, we've gone through in 8 different arrangements. We have our full treatment where it got all 5 treatments. The full treatment, but then we substituted with lactofen to see, is there a difference when you spray with lactofen? Will it promote branching? And we went through, call it a -1. We subtracted one of these out of every treatment to see, well, if I add BioForge, is that going to boost my yield? What's it contributing? And then our baseline is a minus all. We can compare back to that. Have we increased yields? Are these going to help us? That's what we're looking for. Later this winter, we'll analyze yield. That's the true kicker. That's what we're hoping to see the differences. Right now we can see a few visual differences. We'll see those here in a few minutes when we go out, but what we really need is yield. So right now, until we see that yield, don't go out and do these practices.